Hi, Stephen.
Oh, hi.
Hey, good morning. Looks like the recording's on.
Yeah, if I understand correctly, that Huashin's note taker is the one which will take the recording.
Yeah, I think my note taker is on. Yeah.
I have the recording enabled by default, so you should get the Google recording.
Okay, cool. Shall we start?
Let's start.
Okay. Yeah, thank you, everyone. Thank you for joining the meeting. So today we will discuss the Iceberg index support. Peter has a proposal for the overall indexing framework, and I have a concrete phase 1 proposal for the file skipping bloom index stored in Puffin, so which can be served as an example, a concrete example for the index type. So Peter, how do you want to do this? Maybe you can give a quick summary of your proposal, and then I also give a quick summary, and then we will have a few questions we can discuss about that.
I think that sounds nice. Let me share screen. Can you see my screen?
Yeah.
Cool. So let me talk a little bit about the proposal, the idea behind why would we need indexes. So basically, with most of the actual database systems, there are already existing features for making queries faster for specific queries or specific column filters or things like this. We have partitioning, we have sort order, which could make sure that the table data is organized in a way which is primary, working for so it provides a layout, a data layout, which provides a good query performance for these specific queries. But if we have multiple queries against these tables with different requirements, where different physical layout would be useful for these queries to provide good responses, then we don't really have a way to make this happen at this point. So basically, what we would like to provide is a way for being able to query the tables when the actual query is not well aligned with the actual physical layout of the table. And for this, we defined the indexes. Okay, so we defined indexes, we defined index types. So as in every database systems, there are types of the indexes, like P3 indexes by term indexes and so on. So we will have index types, and based on the types, we create specific indexes, instances, like when you are creating an index on the table for column 1 and column 2, and then you can create another index with column 3 and column 4. So the queries which are filtering on column 1 could be fast, and also if they are filtering on column 2, they could be fast as well. So these are the index instances, the concrete parameterized versions of the index. And the index snapshots, which are So basically, Iceberg organizes the data in table snapshots, and the proposal suggests that for the index, we should also create snapshots, and we should connect these index snapshots with the specific table snapshots, saying that this index snapshots corresponds to created based on the data in the specific table snapshot. So these are the main types: the index itself, the index type, the index instance, and the index snapshot. Here is the first thing which is something which I think we should discuss later in this thing, is the layout. We examine different possibilities for storing the index data. One of them was storing the index data actually in the table metadata, like a list of indexes and so on. Or another idea was to store the indexes outside of the table metadata, and there should be only a loose coupling between the index and the table and the index metadata. So in this proposal, we landed on this second solution. So we don't touch the table metadata at all. We create a new index catalog, and in this index catalog, we list the indexes for a given table, and we get the data for this, get the versions and snapshots for the index from the catalog. The storing the indexes in the table has table metadata has several pros for that. One of them is being that the index, the query engine who is reading the table could immediately access the index metadata as well when the table metadata is there. The other advantages pointed out by Stephen, that basically when we are if we want to make sure that the index snapshot is in sync with the table snapshot, then this is currently the only way how we can make sure that the index change committed at the same time at the table change. On the other hand, decoupling the index metadata from the table metadata has a big advantage, that we are able to create indexes for all the older tables, older table versions. So we don't need to modify the index table metadata. We don't need to modify all of the readers and the writers for the specific table if we want to use indexes for the given table. And this was basically the main reason why we landed on this solution, that creating an index catalog, a specific index catalog to store the indexes, and then put this data into the index catalog and make it available for the query engine through that. Here, just a few ways how we can create and list indexes through SQL. And this is here is a few how. So we need to create the catalog also to change it. We need to create the index catalog for accessing the indexes as well. And one of the most important things, how will be the indexes used? My idea about of how the indexes will be used is that the query engine will identify the tables in the query, and then fetch the available indexes for this table. Here we need not all not all of the information for the indexes, but a very shortened version of the information about the indexes, based on which the engine could decide that, okay, this is an index which I could use to speed up my query, or this is the index which is irrelevant for me because either I haven't implemented this index usage yet, or this is not applicable for my query, or I don't expect performance boost if I use these indexes. So we need an API to list the indexes for a given table. Preferably, the user could provide also the index types which it is familiar with or would like to see them. And once the engine decides that, okay, this index seems interesting or this index is interesting, then we need to get not only the summary but the full index metadata from the catalog as well. Here in the indexes, I didn't provide too many details for the indexes. I expect that the users will provide some parameters like for example, for vector indexes, they would like to provide the quantizer function or the centroids or whatever. They could provide some properties from the users, and also another information. I expect that there will be a index maintenance, which would be an asynchronous process which updates the index snapshots based on the table data. This maintenance process could also provide additional metadata, additional information for the specific index snapshot. So I would I would expect that the table snapshots will also contain some properties provided by the maintenance process. I listed the planned REST catalog changes, which are basically the same functions which I described in the API as well, what we expect from the catalog to implement. So it could be usable for the query engines. And here we can go through the exact details of the metadata, but I think at this point it's not really worth to go into very much of these details yet. And then what I would also like to mention that this is only a metadata for the generic indexes, and then we could go to the specific index implementations like Huaxin's Bloom filter index proposal. And I think Huaxin, this would be the point when you can take over and talk a little bit about your proposal. Steven?
So do you want to go through to both and then start discussion, or we're okay to discuss now?
It's up to you. I don't have a strong opinion.
Okay. So I think the first question is about do we want to store some minimal metadata in the table regarding the index? Because I think right now, proposal saying that nothing is stored in the table metadata. We just use list index from catalog and use naming convention on the index identifier in the catalog. And it's also introduce a new index identifier concept in the dog. So I think it might sense to consider that in the table metadata, we store the index definition, kind of like a material view, right? In the material view, we store the kind of the storage table reference, but the actual data can store in a separate entity in the catalog. But some minimal, like, okay, for this table, we have 5 index, second index defined, but yeah, actual data will store somewhere else.
Yeah, I think it makes sense to store some short summary in the metadata file.
My thinking about this is that you will in this point you will rule out to use indexes for V2, V3 tables. It will only indexes will only work for V4 tables because we need to change the specification for the table, and I expect that query engines could issue. So just to make sure that the table by the index identifier stores the table identifier itself, just to make sure that the index identifier is unique. It is not just a naming convention which is making that connected, because when you are creating an index, you are providing a table identifier, which is stating that this is the table identifier which the index is created for. So it is not just a naming convention. If that's the reason you are.
Okay, just quickly before we move to Anton. So, but let's say if you list the index from a catalog, right? You just list by, how do you know this index are associated with which table? You have to pass the content of the index object in the catalog.
Sorry, I don't really get. Can you repeat the question?
If we don't use naming convention, let's say the catalog have 1,000 index objects. How do we know out of those 1,000 which 2 index are associated with the table I'm looking for? You have to pass it.
So when you are creating the index, you are providing the table identifier which this index is connected to, and when the catalog listing requires the table identifier as an input for listing the indexes.
So for more on the Anton.
So I might have some issues with the network.
Yeah, I think my point was that I think we're getting into some of the details of tracking without actually having the use cases talked about and the concrete index types, right? So I think a lot of this would be dependent on that. Like how you track this would be dependent on the concrete index types that we plan to support and how that gonna like interact with the query engine and stuff like that. So I think maybe we can focus on some of those things first, like the concrete indexing, the concrete use case that we're trying to solve, whether it's like getting rid of the equality deletes, or if it's like needle in a haystack type of queries, whether the index is in an external system or is it in files, and like exactly what we are trying to solve. And then I think that would define the design, how this is being tracked in the metadata. But that's my 2 cents.
Okay, so can you hear me? Okay, because I see that there are network issues there. So basically, there are few use cases which we are having here. One of them is the equality delete removal, where we could store the primary key and the file name position in the index, but also another use case is for making timely queries when the physical layout of the table is not matching the query filters, and we would like to have those solved as well. And then Huaxin's use case comes in.
Yeah, I think to Anton's question, I guess we probably have a broad kind of category of index we considering, right? Like technical index. I think that's echoing.
I think for my index, for the Bloom filter index, it's pretty straightforward. So basically, during the planning, the engine will do the normal file pruning first, And then for the remaining candidate data files, it will check the Bloom index to see, it will check the Bloom index. If the Bloom filter proves the value is definitely not inside the file, and then we can prune that entire data file. So basically, you can skip reading a bunch of data files so to make this faster.
So are we now talking about a concrete index, or are we still like in the phase of discussing the overall like possible ways? Because if we talking about the Bloom filter indexes, I have some questions around that, but I just want to make sure it's the right time for doing that. And there also Talat, I think, also has the hand up. So are we in the phase of discussing the concrete index types, or are we still discussing the overall like the overall needs?
Okay, mine is just an example. I think we're still discussing the overall index structure. Yeah.
Okay, then I'll keep my questions until later.
Talat, please.
I have a question about the in general architecture. I thought the indexing multiple times. Why we need to have a catalog? Why we cannot handle these things are using the Puffin file and Iceberg expressions? Do you think that it could be the easiest solution to keep the indexes and to find the indexes? Because indexes basically is planning phase task to determine the which data files or which the positions you are going to read it. I believe the using the Puffin files and the Iceberg expressions to find the indexes could be sufficient enough. Just as a suggestion. By the way, thank you for the index proposal. I was thinking for a while.
Yeah, I'm not sure we should just the limit to Puffin file because depend on the index type. Maybe some other form like a Parquet column form maybe makes sense, but yeah, I'm not sure we have to limit to Puffin file.
But I think there's a big question whether you need an external system or not, right?
Yeah,
and
exactly.
I think like this is the biggest question, because I've been thinking about this for a while as well. And like we had people that had an age-based inverted index running successfully, and they would be storing like the file and the position for a key, and that seemed to work. But there's also this idea where if you or can you actually persist these indexes as Puffin blobs and then deal with them? And that seems like a cool idea, but we have to prove that it would yield the same like planning performance and would satisfy particular use cases, right? So that's why I'm saying that it's really helpful to pick maybe a scenario and then, hey, this is a use case where a secondary indexes is really helpful, and these are the options that we have to kind of solve that use case, whether that's a Puffin-based approach or if it's like, I don't know, an external system-based approach.
Yeah, we should not stick with the technology. I agree for that. But I was trying to say that I believe index has to be part of the table itself, and it should not be modified the catalog side. And then it has to be part of the planning. This was at least my thought.
You're muted,
Yeah. Sorry, I dropped off because some network issues. But if I understood Talat questions before I dropped off, his question was why not just store this stuff in Puffin files and get away with it? My thinking is that we still need to have some references somewhere where we can find the available indexes, the engines can find the available indexes and can share these indexes between different engines. And for that, we need a place to store this data.
Yeah, let me re-ask my questions. The Puffin files can be a technology, as Anton mentioned that, but why we don't store the indexes inside of the table, and also why we don't use the Iceberg expressions to find the indexes? This is my question, actually.
So if you're storing the indexes in the table, then you are very strongly tied the indexes to to the actual table specification. It is the exact same situation with the UTF, the exact same situation with the views, where the decision was that we put those stuff, externalize those stuff, and don't tie those things directly with the table itself.
But even for your catalog proposal, you are tied with the table, right? Because endpoints go to table/indexes.
No,
Oh,
it is not. In a way, it's not tied in the metadata of the table, and that's, I think it's a really big difference.
okay.
Sorry for the wrong network. Yufei?
You are muted.
You still can't hear you.
Can you hear me now?
Yes.
Oh, cool. Yeah, one of the things I want to echo with Stephen is the example that if you have want to search index for one particular table, let's say you have 1,000 index under a certain namespace, then the table identifier itself is not so efficient because you have to list all of them and query all of them, which is the separate entity will cause this kind of issue. Like if you look at the other, like you have to maintain this connection between the table and the index itself, other than if you put it into the metadata JSON file, which reference to another file, it's already there. You don't have to maintain this relationship with another entity, right? And maintaining cost, I think when we build the index, it have to attach one snapshot, because when the snapshot changes, index might also change, and the best thing to use index effectively is to attach one snapshot. When we remove a table or when we expire snapshots, should we also remove all these index attached to this snapshot? Which I think we should, right? And if we store them as a separate entity, how do we effectively do that? How do we effectively do, let's say we have 5 index and each one is for different snapshot for this particular table. How do we know this particular entity index is related to certain snapshot? Again, back to the question, like we needed some kind of a connection mapping table between the index and the table's snapshot in that case. And another implementation I thought about is for catalog. When we have separate entity, it naturally becomes the access control for users, which not part of the IRC or not part of Iceberg spec, to be honest, because we never handled that. But in reality, we have to handle that. Are we going to give different permission to user for different index? If we say it's not an issue, every time you read the table, if you have the read permission for this table, you're okay to access all these index. I think we don't have to handle this kind of issue. Otherwise, if you really want to separate permission for this index for different users, then there's no easy way to split them within one table. You have to store them as separate entity in that case. This is like a point I want to raise, which probably makes sense to let us think through and make better position of overall structure, whether we needed to them into the separate entity or not.
Okay, just a quick question, quick idea or thinking about this one is when you are actually so if you are putting everything into the index, the table metadata, not only just the pointers to the indexes, but also the snapshots and everything, then you will again blow the index metadata seriously. And I think it is really a bad idea at this point when we are thinking about how we can decrease the size of the table metadata. And you are right that we need some connection for the maintenance when we are removing the table and whatnot. But I think we solved this with the UIDs for the views, so probably we can also solve this for the indexes as well.
Daniel.
So mine's kind of a follow-on in that same line as Talit and Yufei's questions, which is like, as written, we kind of are making an assumption about what the model is for index relationship with table updates because they are decoupled. We're kind of saying, well, either you could provide them separately or make updates separately to the table and to the index structure and what it's referenced. You could do that asynchronously, but we haven't really defined what the writer requirements are against a table that has indexes, right? So do all writers need to update indexes? Can writers update the table? And then we're expected that a system is going to update the index asynchronously. Do we have different indexes that have different requirements? Because some may be, you know, maybe covering indexes that like updates wouldn't hurt, or depending on how you index various things, like which files are touched, you may be able to use certain indexes even if they're not fully up to date. So I'm missing the relationship between like how we store indexes and what writers need to do in order to properly interoperate with them. And the concern that I have coming out of that, of course, is if you have a writer that is writing to a table and it completely invalidates the indexes for the next snapshot that it produces, you have these very inconsistent access patterns against the table, where if I hit it and I have an index, then it's super fast query. And then a writer writes data, but we haven't updated the index. And now I get a super slow full table scan, you know, for like a text search example or something like that. And then an index comes in and my performance. So you get like this very cliff or, you know, sporadic performance behavior. So like, what do we want to say about requirements for the producers of data and indexes? I think that's something that we should actually enumerate a little bit more clearly.
I think that we have a very good way to detect the changes. So engines, if could say that this is the last indexed version of the table, and this is the changes coming after that, and this will. So if the engine implements indexes correctly, they could use this change set and apply those after the above the query, and don't experience, the users won't experience this big changes of I cannot use the index at all, I can use the index, I cannot use the index at all, I can use the index, because
but all of this, sorry, go ahead.
So Huashin's Bloom filtering index is a good example for that, because it could be used for filtering out most of the data, even if it is for the old snapshot, and then the new files coming after that snapshot will be scanned, and it will work.
But all of this is dependent on the type of the index and the index implementation, right? So, and like the indexes like that would be an external system would behave fundamentally different compared to a Puffin-based index where you have like a lot more control and granularity. So that's why I'm saying that it's really hard to talk about these generic concepts without knowing the exact index types and their implementations that we're pursuing. Right, because a lot of this will be driven by that.
Indexing is a very generic concept, and I understand. I agree with you that we need to find a few examples to work through that, but we cannot just design a system for one specific index time.
It's not one, but you have to define. So like the way to generalize something, you start with one, then you do two, then you do three, and then you generalize. And then I'm going to test one covering index. I'm going to test one skipping index. I'm going to test one more implementation. And then you would try to generalize. Because right now we're trying to define something generic, and it's too generic that in like if it's going to work for these concrete examples or not.
Okay, if you take a look at the document at the end, I defined 3 types of indexes, which we would like to provide. One of them.
So that's what I'm saying. So maybe we should talk about those, like what exactly they're the types of indexes that we're thinking about, then familiarize, and then kind of this would help us define how this should be tracked and like discuss that.
Okay. I think we should go back to that and discuss that. But there are many hands raised, so we should go through that, I think.
And I'll just ask. So one thing thanks for sharing this document. One thing I wanted to understand was exactly on Yuktai's and Talat's questions. Basically, an index I would require it to help me with either the scan or a seek mostly, or a covering index like for OLAP queries like some count. But in so most of these indexes would be tied to a snapshot, as I understand. And again, I understand why we don't want to bloat our metadata and we are keeping it in a separate place. But I think it's something that we should think about, because an index would really not work without a snapshot in place. It's not really required. Lifecycle, I think, should be limited or it should be around the snapshot itself. Like if we do expire a snapshot, I do not require that index. And in the same sense, I don't not have to maintain this index history and everything, because an index would technically should be tied to a snapshot. It's like my 2 cents around this. It also, I want to add this, that it's possible that certain writers do not support indexes, certain writers do support indexes. And again, whenever a write is happening, a new snapshot would be created. It should the index would be tied to the snapshot, and I think that should fairly help while reading. If you're reading a snapshot and an index is available, then you could utilize that index in place. If that makes sense.
Okay, but that's a good point. My thinking is around that many indexes. Many of the writers will not understand the indexes. We cannot say that if the table has an index, then every writer for a given table needs to write the indexes. That's a very, very hard requirement, and I'm not sure that we are in a position to do that requirement. And this decouples the actual table data from the index data in my head.
I agree with that, but again, any writer would create a new snapshot, and an index would always be tied to that snapshot. So if a new writer which doesn't support writing indexes, there won't be any, the snapshot will be created, but there won't be any index attached to it. And while reading, we'll always read from a particular snapshot, is what I understand. So,
next could be updated asynchronously with another system, index maintenance, which could update the data, and then it should update the table snapshot, and this becomes a little bit tricky if we tie everything there.
Okay, that's also a good point.
Okay.
That.
Thank you. I think I want to basically maybe echo Anton's point. I think it would make it much easier if you would start concentrating on like types of indexes and then see what each one of them like require, and then maybe go a level deeper. Broadly speaking, if I'm like looking at both your proposal and Roxanne's proposal, I see that there are like different, I would say, groups of indexes. There are like planning indexes where you have some information stored per file and you can consult them to decide which files are relevant. There are some in which I would call here a secondary index, where you basically point to a specific row in a file, and then you need to basically read those rows to get the data that you want. And there are like also covering indexes, which you mentioned also in your document, where you actually store the columns themselves. And each one may require a different like a location to store the metadata, and different ways to update it, and also a different discussion about like whether all the snapshots are relevant for that index or not. So I think it would make sense to maybe start by focusing on either the categories or more specific indexes, kind of like the Bloom filter is an example for this one, and then maybe the B-tree or whatever for the other one, and then build from there and see what we get.
Okay. Any other questions? Okay, so then I think if we talk about Huashin's proposal, it's a good one example which we would like to cover. So that would be a good step forward, and then we can move forward with other types if we still have time. Huashin?
Okay. So my proposal is for the Bloom filter index. It's pretty straightforward. So if we create a table, if we want to create an index, and then we will currently in my proposal, I store the Bloom index in the table metadata. But if we get an agreement to we want to switch to catalog, I can switch to. But currently, I store the index inside the metadata. So basically, I have the I will save the index in the Python file, and inside each of the Python file, it has a bunch of blobs. So basically, for each of the blob, it's corresponds to a data file. So during the planning, the engine will do the regular pruning, and then after the regular pruning, it will check the Bloom filter index to see if a specific if the data file contains a value or not. If it turns out the data file doesn't contain that value for sure, we'll just prune that file. We will not read that file. So that's the basic concept for my proposal. Anton.
So basically, you're saying there's going to be one blob would represent the Bloom filter, and there's going to be one per file.
Yeah.
Is the plan to store like one Puffin file, or is it going to be like multiple Puffin files, or what's the story there?
I'm thinking of one Python file, but I also think it might be a possibility that the index doesn't fit one Python file, and then we need multiple.
Okay, and how does this compare to the existing Bloom filters in Parquet, which also exist at the file level, right? So it's technically today, the way the planning works is, first of all, you do the planning normally, you determine the set of files, and then on the executors, you fetch the footer, where you basically may have the indexing information, and then from there, you check if you need to actually read that file or not. So by moving that to the driver, instead of doing that in distributed fashion on executors. So what do we gain there? Like, do we have an estimate? Like, is there going to be a speed up in this operation, or what do we gain? Because now we put more pressure on a single driver instance, which would essentially access the same Bloom filter blob that you have at the file level. So what's the benefit?
I think the current support for the Bloom filter in Iceberg and Parquet is at a row group level. We don't really have a file level Bloom filter yet, if I understand correctly.
I mean, so technically yes, but like you can check it at each row group for a given file. So even like if it's like I would argue that probably even has a higher precision, right? Or the lower false positive rates because it's per row group. If you were to aggregate that and do it per file, then likely, it's going to be an aggregated one, right? So like, what's the benefit? What are we trying to optimize in this case?
So I think right now we're doing the 2 level of bloom filter. So currently we only have a row group bloom filter spot. So we have to open the file first and read the row group. With this bloom filter index, we will do one more level of the pruning at the planning phase. So at the planning phase, if it turns out the value is definitely not in the data file, we don't even need to open this file later. We just prune the file out. So we're gaining the performance here. I don't have a benchmark yet.
So it's basically the to avoid the overhead of scheduling the tasks that we don't have to, you wouldn't have to otherwise. Is that correct?
Yes.
It also reduced the the blob storage call, right? Then basically it will reduce the cost for the blob storage too. It's exact same what we have for the deletion vector.
Yeah.
I think guys next.
I think that it has the potential of 2 benefits. It's like as it was just said, like reducing the number of calls to object store to read like very small metadata for each file. So there is a benefit of consolidating them, but I think it's not necessarily that we would be able to only use the driver to do that. I think that the benefit of consolidating all of these bloom filters together to one single location is being able to read them at once and then process them in batch. But even then, maybe the driver alone will not be enough to gain a good performance. We may need to distribute that, but and you have to access less files during that planning phase.
I think that here we would be helpful to understand again to do the estimation on what would be the size of each blob and how's this puffin file gonna look like and how much of it you would have to pull on the driver. So I would understand that if you're not triggering the false positive tasks, it's going to be beneficial, and that you're also reducing the number of storage requests potentially. But like, what's that? Like, you're doing more work on the driver, so how scalable that's going to be? What's the size of the blobs? What's the size of the puffin file? And what's the limit of what driver can do here? I think that would be helpful to reflect in the proposal.
I agree with this. I don't think we need to couple this with doing this on the driver. I think there is one benefit from consolidating the bloom filters together to one file and then reduce the number of object store calls. And then there is the question whether you run on the driver or you still run in a distributed way, and then you have multiple executors accessing this consolidated storage. So they need not go together.
Do we have distributed planning? And what about catalogs who are doing the planning? They can all benefit from that and then can do distribution and whatnot.
But we need to measure the concrete benefit of this consolidating, right? Because like technically you could, in distributed fashion, you could go and look for those bloom filters in files or something. It's just like we need to have some numbers that actually prove that it's going to yield the benefits that we're expecting.
I think we also, I would, first time seeing the doc, it looks like we have a good explanation of like maybe potentially how we lay out, how we do planning, but what does it mean for updates and how does that affect the structure of the puffin file and what we want to capture? Because, you know, if you've got really large tables and then you're doing updates, but we're all co-locating within a puffin file, like how do we do updates against the index?
I think we'll just do the incremental update. So for the original table, if it already have the index, the puffin, I mean the bloom index, and then for the new files, if it doesn't have the bloom filter index yet, it's okay. Just for that, that's the new files. We just don't do the pruning by bloom filter.
Okay, for me, I think the boom filter is a good example of where we should do like inline synchronous maintenance of the index. Just the writer maintain that index as we write the file. I think that actually makes sense to me.
Well,
You
so
probably can.
I think we need to define if we think that that's a requirement or not, and what the behavior is with, incomplete indexes. And then like, what are the update requirements for new production of it? Because then we're talking about like multiple Puffin files over time, right? We're not talking about consolidating everything into one. And so like, we're taking kind of this perspective of like, well, here's a full table state and here's how we had a Puffin file to cover that full table state. But I think we need more of the incrementality of like, how do operations, both for like removing things from it, adding things to it, how does that evolve over time? Sorry, Anton, did you have something?
Yeah, so like exactly on that point, because like if we started with the idea that we would have one Puffin file was the blobs, then if you were to like maintain this, then you would have to rewrite that file if you modify, let's say, one or two files, or you add to it. So you basically have to copy over all of the previous blobs and how big that's going to be, what's the storage footprint, and like if you don't do this, then you would accumulate multiple Puffin files. And then at some point it would be useless because you would have too many Puffin files. So you would basically have to open too many on the driver. So this would kind of diminish the benefits as well.
So a quick question. When we talk about table update, I talk about delete files or talk about delete rows from data file.
Delete files. I don't think rows really matter because like you would overmatch on the index and you just apply on update. So it's probably the same for individual rows being deleted. It would probably be the same thing. But I do think that that's a good thing to cover and make sure that we address those questions just so people aren't assuming.
For the delete file, I think we can kind of do something similar to dRewrite. The Puffin file doesn't have to rewrite, but we can delete the entry from the boom filter reference. Can we do that?
Well, you don't need to necessarily delete things from the Bloom filter, right?
Yeah,
Because
no, we don't.
You wouldn't go looking for that one, or it would never match. So it may be okay to accumulate, but then at some point, to Anton's point, you have to do maintenance against these things. Because some get carried forward, some get rewritten, and so something needs to know about how do we and when do we rewrite anything just to reduce the overall metadata for the table and index data.
I think the Bloom filter is a very, very good example for a filter index which could asynchronously update it. Because if you don't update the Bloom filter for 10 snapshots, then you still have a very good, very useful Bloom filter index. And you can use that in your planning, even if it's for a very, very old snapshot. And then you just get not that effective with that.
Yeah, I actually have a different opinion because I feel the boom filter is much easier. It's cheaper to maintain synchronously because when the writer writes a row to the file, it already have the row. It can just it's very cheap to just update the boom filter index.
Yeah, it's just rewriting the in-memory dataset.
Yeah,
it's again a requirement against the writer. Do we want that?
Well, I think for some index like boom filter, I feel might make sense to as a requirement writer. For other index, more complex index like vector index, search index, they are probably not. But I feel boom filter is a little bit with special index. It always has a one-to-one mapping between the index and data file, like DV. It's actually very similar to DV.
And also, it's easy to maintain the snapshot version of those Bloom filters too.
Yeah, I'm also thinking maybe in the column stats, maybe we can put that actually as a field at column stat, which have a reference to the Puffin file for the blob. And when we delete data file, the reference also deleted. It's kind of DV, right? We can delete the DV reference, but the Puffin file don't need to be rewrite immediately. Yeah, over time we compact them, but I feel it's kind of maintained a little bit similar to DV. Yeah, and I don't mean we store the blob in the column stat. I'm saying maybe store the reference to the Puffin blob in the column stats.
No, that was unrelated to your point, but it's just like we're trying to apply the same principle that we have for the min-max values, where like we try to aggregate the min-max values that we get in from the Parquet file, from the row groups, and then into the data file level stats, and then persist that in the metadata so that we don't have to open the footer to do this. And it seems it does work really well, but it's much smaller than the size of the Bloom filter that would be needed, right? So like we have to be careful. I'm not saying you shouldn't do it or it's not helpful, but at least we have to be mindful, and we have to prove that, you know, like doing this extra work somewhere on the driver, for instance. If we were talking about not scheduling the extra tasks, then you have to do this on the driver, because if you need to do this in a distributed fashion, then you already schedule the tasks. So what's the difference compared to just checking the Parquet Bloom filter in that case, right?
I don't want to hijack the things, but we only remain the 2 minutes. I just want to ignite a discussion. Just, you know, maybe we can discuss on mail list also too. Why basically either way, you know, having a puffin files or having a indices, this is very obvious, right? On the planning phase, we need some kind of external calling. It can be a puffin file or something else. Do you guys think that should we introduce a pluggable phase for the planning? It can be used by the indexing, or it can be used something else, you know, like, for example, data masking, or I don't know, you know, just two example. It just came in my mind now while we are discussing. But do you think that is it valuable to have a pluggable planning phase which can, you know, plug something else?
I feel like that's more of like an implementation detail than it is a specification detail, right? So
yeah, it's not specification, it's just extension point for, you know, the planning phase.
Yeah, so I would separate that from the discussion of like how do we do spec work on these kind of things, because and that can come up in the reference implementation. It'll probably cross multiple of these, like, hey, if we're doing data protection or, you know, something else, like what is the phasing? So I just think that's a separate discussion than the spec work.
Okay.
So for the next step, I think should we do what Anton was suggesting? Maybe estimate this kind of if we do the Bloom filter in the puffin file, even with the distributed planning, how much compared to the task that scan the Parquet footer? Can we maybe do something?
I think if we want to tie these together, maybe if we can update the doc, because the doc looks like it's written independent of the like secondary indexes, like overarching kind of how do we track metadata. So if we could update that in context and then add some of these areas, like, hey, what are the performance characteristics? How do we deal with like the life cycle of a table as files are added and removed, synchronous versus asynchronous kind of requirements on updates, like, you know, is it necessary? Do we rely on asynchronous? Do we require it for writers? So there's a number of things that we probably need to enumerate. And I think, Anton, I don't know if you had anything else.
No, I mean, like, I would love to see. I'm not discarding the Bloom filter at the file level pre-aggregated, but that's just all I'm saying. We have to be careful because this is fundamentally different from the min-max values. Technically, you could have pushed the same idea, and you would say that the data entry is going to store an optional pointer to the Bloom filter or something, right? And you could have said that I'm going to pre-aggregate my Bloom filters for row groups into one per file, just like we do with the min-max. And then you don't need to do anything extra for the way you kind of keep the indexes around and stuff like that. So it would be just part of the data entry or something.
Yeah, that's like with the new stats representation. And potentially even bringing in other things, like what is the alternative of like just keeping that as a statistic value that you rewrite in the metadata or something like that?
Yeah, or like a pointer to, like, it would be a part of the statistic that you keep, but it's going to be maybe not necessarily the blob itself, but maybe a pointer to the blob or something like that, right? So like you can get creative with this.
Yeah, I mean the independent column thing would potentially work in this case too, right? So if you don't want to pollute the metadata files themselves with the Bloom filter size, using appended columns for that is another avenue. So I think it's worth exploring all of these and making sure that, like, you know, yes, it can be done this way. Is that the right way to do it, and do we get the benefits that we're expecting out of it?
Yeah, sure. We will change the proposal and address this comments in the proposal.
Okay.
Yeah, thank you so much for joining the meeting. I will send out the note and the video. Thank you. Yeah, bye bye.
Thank you. Bye.
Right.